In 1996, the federal government required every new vehicle sold in America to carry a computer that talks. Every truck built before that date speaks a language the system was never designed to hear. The screen reads back 3 words. No data. Diagnostic link not detected. The truck in the lot is a 1994 Ford F-250, 7.3-liter IDI diesel. No check engine light, no OBD-II port, no data link to anything. A machine the system cannot read. This is the story of a date, January 1st, 1996, and the 30-year-old loophole it accidentally created. Congress did not leave the OBD-II deadline to chance or the calendar. The Clean Air Act amendments of 1990 set a clear demand. Every new light-duty vehicle must carry an onboard diagnostic system, but the trigger would not be the build date, the sale date, or the moment a truck rolled off the line. The law uses a more nuanced device, model year. In the legal text and the resulting EPA regulations, model year is defined as the year assigned by the manufacturer, regardless of when the vehicle is actually built or sold. This distinction is not a technicality. It is the backbone of the compliance system. During House and Senate committee debates, lawmakers and staff zeroed in on the industry's design cycle. Automakers do not retool engines and electronics overnight. By anchoring the OBD requirement to model year, Congress gave the industry a predictable timeline. 3 to 4 years of lead time, enough to redesign control modules, test new sensor arrays, and align product launches with regulatory deadlines. The House Energy and Commerce Committee spelled it out. The model year approach prevents a mid-year scramble, avoids disruption of model changeovers, and lets the EPA enforce the rule cleanly. The Senate's floor debate confirms the intent. A model year trigger ensures a hard regulatory line that matches the industry's annual rhythm, not the chaos of rolling deadlines tied to production dates or dealership sales. The EPA translated this statutory logic into rulemaking. The 1993 OBD rule and the 1996 final rule both repeat the model year language. OBD-II is required for all gasoline light-duty vehicles designated as model year 1996 or newer. Diesel light-duty vehicles follow in model year 1997. The rule is blind to when the truck was actually assembled. What matters is the badge on the door jamb, the VIN code, the manufacturer's own assignment of model year. This is not just legalese. It is the fulcrum that flips a vehicle from analog to digital in the eyes of regulators. For the DMV, this system means every compliance check, every scan, every registration lookup begins with a single question: what is the model year? If it is 1996 or later, the expectation is digital transparency, a 16-pin port, a stream of standardized diagnostic data, and a vehicle that can be interrogated by any certified scan tool. If it is earlier, the system expects silence. No data, no digital handshake, no emissions monitor status. The model year device is the gatekeeper. It draws a line that is both clear and deeply consequential, dividing the fleet into those that must speak and those that are allowed to remain silent. This is how a statutory definition, buried in committee reports and regulatory dockets, becomes the practical reality at every county DMV window in America. The regulatory clock did not tick forward all at once. The EPA's OBD-II rollout unfolded in deliberate, staged increments, each milestone stamped into the Federal Register, each date a dividing line that still governs how trucks and cars are seen by the law. The first wave arrived for gasoline passenger cars in model year 1994. This was not a test batch or a voluntary program. Every new gasoline car labeled as a 1994 model was required to carry the new diagnostic system, an electronic watchdog ready to report on its own health through a standardized port. For many manufacturers, that meant redesigning control modules, rewriting software, and rethinking dashboard layouts, all to comply with a federal order that did not blink. The next year, the requirement crept outward. Model year 1995 swept in gasoline light-duty trucks and SUVs, vehicles that had often escaped the most aggressive emissions rules in decades prior. Now, even a new half-ton pickup or a family van had to carry OBD-II hardware and software, regardless of whether the buyer ever intended to use a scan tool or even knew what those three letters meant. The rule cared only about compliance, not convenience. Then came the hard line, model year 1996. The EPA's final rule, published as 61 FR 21946, declared that every gasoline-powered light-duty vehicle built for 1996 or later must be fully OBD-II compliant. No exceptions, no regional carve-outs. Any vehicle wearing a 1996 model year badge, whether it rolled off the line in late 1995 or sat unsold on a dealer lot until the following summer, fell under the new digital regime. The law did not care about the build date or sale date. The model year, as assigned by the manufacturer and encoded in the VIN, became the only date that mattered. Diesel vehicles received a brief reprieve. The EPA granted manufacturers until the 1997 model year to bring light-duty diesel trucks and passenger cars into the OBD-II fold. For one more season, a new diesel F-250 or Ram 2500 could still leave the factory with analog guts, invisible to the scan tools that state inspection stations were just beginning to deploy. But by 1997, the same digital expectation applied. A 16-pin connector under the dash, a stream of standardized data, and a vehicle ready to answer the system's questions. These milestones, 1994 for gasoline cars, 1995 for gasoline trucks, 1996 for the full gasoline fleet, and 1997 for diesels, are not just regulatory trivia. They are the backbone of the modern compliance system, the reason why a 1994 Ford F-250 can slip through DMV registration with barely a digital footprint, while a 1996 model is interrogated at every turn. The timeline is not a relic. It is the living boundary that divides analog silence from digital transparency, and it is written into every DMV database, every emissions inspection program, and every scan tool protocol in the country. Under the dashboard of every light-duty truck built since 1996 sits a silent, rectangular port, the SAE J1962 Data Link connector. 16 pins, each with a precise role, form the backbone of a digital system Congress required for all new vehicles. Pin 16 supplies battery power, pins 4 and 5 are grounds. Pins 6 and 14 carry high-speed, CAN signals in newer models, while pins 7 and 15 support older ISO and K-line protocols. The port is no accident. Federal law demands it be within reach, no tools needed, always ready to communicate. Plug in a certified scan tool and the system responds with a handshake, a voltage pulse, a burst of binary, a declaration that the vehicle is ready to be interrogated. The tool requests a list of monitors, catalytic converter efficiency, oxygen sensor response, evaporative emissions integrity, EGR system function, fuel system pressure, secondary air system activity, and misfire detection. Each monitor is a self-test, a digital checkup the engine performs on itself. The results are stored as status bits in memory. The scan tool reads these bits, has the test run, did it pass, is the system ready for inspection? The answers come back as readiness codes, each a digital yes or no. The OBD-II protocol is strict. Diagnostic trouble codes, abbreviated DTCS, follow a 5-character format. P stands for powertrain, B stands for body, C stands for chassis, U stands for network. A P0300 code means random misfire. P0420 signals catalyst efficiency below threshold. These codes are universal across Chevrolet, Ford, and Toyota. It makes no difference. The EPA requires that any certified scan tool can retrieve these codes, no proprietary equipment allowed. In any shop or DMV lane, the tool can interrogate the vehicle, pull its monitors, and print a compliance report in minutes. The system is about more than finding faults. It is about proof that the vehicle has checked itself, that emission-critical components have passed their self-tests, and that the results are available for inspection. Readiness monitors are divided into 2 groups: continuous monitors, misfire, fuel system, and comprehensive component run whenever the engine is on. Non-continuous monitors, catalyst, evaporative system, oxygen sensor, and EGR require specific conditions, a warm engine, steady throttle, certain speeds. If a monitor has not run, the tool reports it as not ready. Too many not ready statuses and the vehicle fails inspection, even if no faults are found. Every part of this diagnostic system is grounded in federal rulemaking and the SAE J1962 standard. The port, the pins, the codes, the monitors, they form a contract between vehicle, owner, and regulator. The scan tool enforces it. If the system responds, inspection proceeds. If not, the process stops. For trucks built before 1996, none of these rules apply. For trucks built after 1996, every inspection and registration depends on what the port reveals. A 1994 Ford F-250 7.3 liters IDI diesel waits in the DM5 inspection bay. The technician reaches for a connector that is not there. No SAE J1962 port, no 16-pin rectangle, no handshake. The scan tool blinks, no data. For this truck, silence is not a malfunction. It is the outcome the system expects. Every pre-1996 truck is built this way, by design and by law. The divide is stark. OBD-II vehicles from 1996 onward are built for digital interrogation. Their modules run self-tests, store readiness codes, and respond to any certified scan tool through a standardized protocol. The J1962 port is always present, always ready. But pre-1996 trucks follow a different script. Manufacturer manuals from the early 1990s describe a patchwork of proprietary connectors. Sometimes a 2-pin plug under the hood, sometimes a single-wire test lead, sometimes nothing at all. Each brand spoke its own language, followed its own diagnostic rituals, and none were required to answer a government-mandated tool. Scan tools built after 1996 expect a conversation, a request for powertrain data, a reply with monitor status, a list of diagnostic trouble codes. But when plugged into a 1994 F-250, the tool finds only dead air. There are no readiness monitors to poll, no P codes to retrieve, no evaporative system status to report. The engine control module, if present, is analog and silent by design. Even the most advanced scan tool cannot conjure data that was never structured, never stored, and never meant to be shared. The result is a null response, a refusal to participate in the digital inspection regime. This silence is not a loophole, it is the direct result of the regulatory timeline. Before OBD-II, there was no federal mandate for a common diagnostic architecture. The Clean Air Act amendments of 1990 set the clock, but did not reach backward. Trucks built before the model year cutoff were left as they were, analog, unconnected, immune to the new rules of digital compliance. The absence of a J1962 port is not a missing feature. It is a declaration of independence from the digital grid. The truck cannot be scanned, cannot be remotely monitored, and cannot report its own emission status to any centralized system. For the DMV, the process is straightforward. If the registration database flags a pre-1996 truck, silence is expected. The system does not wait for digital readiness codes or self-test results. Inspection defaults to a visual check or, in many states, no emissions verification at all. The inability to answer is not an error. It is a regulatory gray zone, preserved in law and hardware, where the analog truck remains invisible to digital oversight. This is not a technological failing, but a structural boundary, enforced by the absence of a port. Inside the smart driver scandal, the raw scale of data capture stands out. General Motors, through its OnStar platform, collected telemetry from vehicles at a rate that would make most surveillance systems blush, up to every 3 seconds. Each interval brought a fresh packet, precise GPS location, speed, hard braking and acceleration events, seatbelt status, even the hour and weather at the moment of travel. The technical appendix to the FTC complaint spells out the process. The car's embedded modem streamed these details straight to General Motors servers, where they were sorted, matched to driver profiles, and bundled for third-party brokers. The numbers are not abstract. At the time of the FTC investigation, OnStar Smart Driver was active on roughly 8 million vehicles. That figure comes directly from General Motors' own filings, 8 million cars and trucks, each producing a continuous log of driver behavior, location, and risk signals. The system did not discriminate between those who understood the fine print and those who did not. Enrollment was often automatic, triggered by a new vehicle purchase, a software update, or a dealer-activated trial. Many drivers never saw a warning, let alone an explicit consent dialogue. The data stream began the moment the ignition was switched on. The FTC complaint details the frequency and granularity of the collection. 3-second intervals meant that a single commute could generate hundreds of data points. Every turn, every stop, every surge of acceleration, all mapped to a timestamp and a breadcrumb trail of locations. These packets were transmitted in real time to General Motors Cloud, then relayed to data brokers like LexisNexis and Verisk. The brokers, in turn, sold risk scores and driving histories to insurance companies who used the information to adjust premiums, often without the driver's knowledge. The technical evidence is unambiguous. The data pipeline was engineered for scale and invisibility. No special hardware was needed beyond the factory-installed OnStar module. No warning lights, no dashboard indicators, no opt-out button on the radio. The system was designed to harvest and transmit, not to inform or empower the owner. This was not a one-off experiment or a rogue app. It was a fully integrated, manufacturer-backed operation, running quietly in the background of millions of vehicles for years. The result, a vast, invisible archive of American driving, was built on the promise of safety and convenience, delivered as a commodity to the highest bidder. Honda's contract with LexisNexis spelled out the terms in black and white. Nearly 97,000 vehicles, each data stream sold for 26 cents. Hyundai's deal was even bolder, 1.7 million vehicles, 61 cents apiece. The transfer authorized in internal memos and confirmed by broker payment schedules. These are not isolated incidents or technical footnotes. They are line items in a growing business model, one where the car's voice is packaged, priced, and delivered to data brokers who turn driving histories into risk scores and insurance premiums. The logic is systemic. If a vehicle can report, someone will pay to listen. Industry spokespeople describe these arrangements as OPT-in, but the mechanics often tell a different story. Consent screens buried in infotainment menus, toggles preset at the factory, disclosures written in legalese, each step designed to nudge drivers past the point of no return. The result is a data pipeline that runs quietly and invisibly from the dashboard to the broker's server farm, bypassing any meaningful pause for owner approval. The numbers are not lost on Capitol Hill. In June 2024, Senators Ron Wyden and Edward Markey issued a joint press release calling out what they termed a consent charade. Their letter to the FTC, dated July 9th, demanded a rulemaking that would require explicit, informed consent before any vehicle-derived data could be sold to third parties. The senators' critique is direct. The auto industry has built a parallel market for driver telemetry, one that trades on opacity and inertia. They argue that the existing regulatory framework is not keeping pace with the technical reality of connected vehicles. The payment schedules, 26 cents and 61 cents per car, are not just accounting trivia. They are evidence that the sale of driving data is now an industry-wide practice, not a rogue experiment. From GM's OnStar to Honda and Hyundai, the pattern is clear. If a vehicle is capable of transmitting, the market will find a way to monetize its silence or its speech. For every owner whose truck cannot be scanned, these numbers are a reminder. The analog divide is not an accident. It is a firewall built by the absence of a port, a protocol, or a handshake. The stakes are no longer theoretical. They are measured in dollars, contracts, and the letters of senators who see the pattern for what it is. Some machines still refuse to confess. In a landscape where nearly every vehicle is interrogated, pre-1996 trucks remain unreadable, neither suspicious nor obsolete, but sovereign. The regulatory line drawn in 1996 now marks the frontier of automotive privacy. For those who choose analog, ownership means silence. A truck that does not rat, a driver who answers only to the road. The system listens, but some engines simply do not speak.